So we are talking about rectilinear motion. Rectilinear motion. Okay? And so remember what we discussed the other day is that an object moving through space has four qualities. Well, it has lots of qualities, but it has these four qualities. It has a position, it has a direction, it has a speed, and it has influence on speed and direction. And what we said is that speed and direction are combined into a single quality called velocity, right? And that influence on velocity is called acceleration. And then do you guys remember the most important thing for answering questions in a calculus class? What did we conclude with? That velocity is the derivative of position, and that acceleration is the second derivative of position, or the derivative of velocity, right? It is the rate of change in, okay? So anytime so let me give you the first, this is just sort of a, you know how you have little hints and clues and tools in the back of your mind that help you answer questions? I want to give you one of those right now. Anytime you see the word velocity in a question, if you are wrestling, what's that? Did I say a rhyme? There you go. Anytime you see velocity, okay? We live in a velocity. It's the greatest city in the world. Anytime you see the word velocity, you can strike the word out, and in its place, over top or underneath, you can write in the phrase rate of change in position. Okay? And anytime you see the word acceleration, yeah, well, we wouldn't really say it that way. You can replace that with rate of, although that's what it is, rate of change in velocity, which now actually, it's funny you said that, because now, yes, we could strike out velocity and write rate of change in position, right? And now we can read the definition of acceleration as the rate of change in position. And I know that's frustrating, but yes, you can do that. Okay, let me give you an example. One of a very simple to solve problem that confuses lots of students is the question: what is the average velocity of an object over the interval? So let's say, I don't know, let's say we have some function. We have some position function x of t. X of t means x position, the left and right position at time t, right? So we have x of t, y of t, and z of t, right? In a calculus class, we don't really do z of t all that much, but I did put z of t, one question on there that says z of t, okay? Sometimes they'll do s of t. I think that's an older position variable. Nowadays, we do more x of t and y of t. So let's say that the position is x of t, and the question will be, what is the average velocity on the interval from 4 to 11, let's say. You got some interval. You have to be given an interval to identify an average velocity. Okay? Now, right now, you guys probably couldn't answer this question. You're probably not sure how to answer the question. But I'm going to change the word velocity here. I'm going to do what I said we could do here, and it's going to possibly open your mind up to something we did last semester. Okay? So what am I going to do? I'm going to, with a different colored pen, I'm going to cross out velocity. Well, let me cross it out with a black pen because I don't want to put black ink on the blue pen. We're going to cross out velocity, and we're going to write in rate of change in position. Rate of change in position. Okay? All right, now let's read. Yes. Slope of what? You're right. It's a slope. Ready? Now it reads, oh, I didn't put a question mark at the end. Now it reads, what is the average rate of change in position on the interval from 4 to 11? You did a quiz that asked questions just like that. Only instead of saying the word position, they said f of x. So we can cross out. Yeah, go ahead.
X of 11 minus x of 4 over 11 minus 4.
Yes! Precisely. Exactly.
Yeah.
But do you know how many of my students will put x of t here instead of position? Okay, so now it's what is the average rate of change in x of t on the interval from 4 to 11? Do you know how many of my students, to answer this question in the past 6 years, did v of 11 minus v of 4 over 11 minus 4? You know what they gave me? They didn't give me the average velocity.
The average acceleration.
They gave me the average acceleration. That's correct. Yes. Sorry. Of a position function. A function telling you how far an object is from some origin point. Okay? So, let's say the origin point is right there, and we are right of that origin point. Right now we're about 8 feet right of that origin point. So the dart is starting off 8 feet to the right. That's a positive position. Now, as I shoot it that direction, isn't it going to get closer to the origin point, which is 0? So the distance is going to decrease. Then the distance is going to decrease some more, but in the other direction. But it's going to increase in the other direction, in a negative direction, which means decreasing. So now it's in a positive position. Now it's in a negative position, and now it's almost back at 0. It went from a positive position to a negative position, then almost back to 0. Does that make sense? So x of t is just a function that represents the position of an object, how far it is from a point at any particular time. In whether time is in seconds or minutes or hours or whatnot. Okay? So, seismologists, geologists, right? They might be measuring the distance that one plate, a point on a plate, a tectonic plate, is from another point on a different tectonic plate, right? And as those two plates are moving over years or months or whatnot, they can draw a graph of the distance. Does that make sense? I don't know if you're a geologist or seismologist or any of that, but we can do this with anything. We can do it with, for Newton, it was the apple's distance from the ground. It started out 10 feet from the ground, and then over, a few seconds, or over a second or a second and a half maybe, the distance decreased until it reached the ground and had a distance of 0. Does that make sense? So what we're doing here is this. So when we identify the average rate of change in the position, or x of t, we're identifying the average speed with direction of the object. Okay? So if the average velocity winds up being like negative 2 feet per second, that means that the average speed, not at any one particular time, but from the time something started at 4 till it ended at 11 seconds, its average speed was 2 feet per second. If you were to give the same speed to every second in the interval, it would be 2. Okay? I don't know if this is making sense. I'm trying to bridge the gap between the abstract conceptual and the practical, hey, I need to be able to solve a problem on a piece of paper. Okay? All right, let's go to the worksheet now. Now that I've given you this little clue here that can help you answer these. Not maybe, I don't know how many of these questions it can help you with, but it can help you with some questions. Because we're running out of time, because I want to give you a test next week, your test is going to be next Friday. We're going to review on Wednesday. I'm going to give you and that's the next time I see you, by the way. I'm going to give you basically a review sheet, and it's going to be equal to the test in a sense. What's that? No, I'm sorry, Wednesday I'll give it to you. Yeah, I won't see you Monday because of MLK. So the next time I see you, I'm going to give you a review sheet, and then it's going to look like what the test is going to look like on Friday, just so that you can prepare. And I will try to make sure that it's just enough questions that will only take you about an hour and a half. Okay? Actually, it shouldn't be an hour and a half. It should be an hour and 15 because RCA folks have to leave. Okay. Let's look at this. All right. Do you guys notice that these are the same questions? Let's see. A, B, C, D, E, F, G, H, I, J, K. It's about 11 questions, but some of those questions are more than one question. And here's what I want to do is I want to talk about what each of these answers means. Okay? So, question A on each of these. So in each one of these situations, you are given a function, and you are told that that function is the position of the object, right? So it says an object is moving left and right along the x-axis such that its position is x of t is equal to t to the fourth minus 13t cubed plus 56t squared minus 92t plus 48, right? It's a polynomial that does this. Or, well, for you, it does this. Something like that, right? Is it fourth power? And it's positive, so it does this. Okay? That means that the object is traveling one direction, then changes direction and turns around, then changes direction and turns around, then changes direction and turns around. Okay? And so the first question, part A, you have to be able to answer this on this test. What is the object's velocity as a function of time? What am I basically asking you there?
What's the derivative of x of t?
That's it. What's the derivative of x of t? That's what I'm asking you. So, the velocity is going to be whatever the derivative of x of t is. Okay? Right? So anytime you are ever asked what is the velocity as a function of time, all they are asking you to do is identify the derivative of position. Are you okay, Michael? All right. You look either frustrated, angry, or are you okay? All right. So now I want to warn you about something because we are only 2 weeks away from learning antiderivatives. Well, with antiderivatives, if you're asked what is velocity as a function of time, you may be finding the derivative of the position function or the antiderivative of acceleration. See what I mean? Because it's backwards. That's what integration, antiderivatives, is backwards derivatives. So you could actually find the velocity of a function by starting with the acceleration of the function. But you need a little bit of additional information, but I'll teach you how to do that later. Okay? All right. Question B asks a similar question. It says, what is the object's acceleration as a function of time? Well, so what would you have to do for that question? Second derivative of the position function. So a of t, or what else could we call it? The derivative of velocity. So in some situations, you won't be given the position. You will be given the velocity function and then asked for the acceleration. Okay? All right, so acceleration is either the derivative of velocity or the second derivative of position, which you should know how to do from last semester, right? So I don't want to go over how to do derivatives. Okay? Yes. When they say, what is the velocity of the object as a function of time, they are asking you to explicitly state the function. Okay? They would expect you to write out the derivative of whatever they gave you as x of t. Okay? Which is convenient because then you can use that information to answer other questions. Once you have the analytical function for position, the analytical function for velocity, and the analytical function for acceleration, you can answer any question about the motion of that object. Anything. Which is pretty awesome, pretty powerful, if you ask me. Okay. Question C. Notice we're not answering the questions. We don't have time to answer all these questions right now. I mean, if we have time at the end, I want to get through how to answer them first. Then if we have time, that's one of the reasons I gave you the answers, so that you can work on finding the answers. It says, what is the object's initial position, initial velocity, and initial acceleration? Does anybody know what the word initial means in physics or in...
When time is 0.
When time is 0. That's what it means. Initial means the word initial, plug in 0, means when time equals 0. That's what it means. Plug a 0 in.
When I was looking at the key, I noticed that it's basically the constants of all the different...
You know why that is?
Because
Because these are polynomials. But it will not always be that case. If your function is trigonometric or exponential, then it won't, well, it depends. Like sine will still be the constant, okay? But cosine at 0 equals 1. So if you have cosine of t plus 5, then the initial position would be 6. Because cosine of 0 is 1 plus 5 is 6. Does that make sense? So yes, if it's polynomial, you can count on the initial position, initial velocity, initial acceleration being the constant. Yep. Okay. So for C, basically what you're identifying is for initial position, okay, that's just whatever x of 0 is. The initial velocity is whatever v of 0 is, and the initial acceleration is whatever a of 0 is. Okay, just plug 0 in to these functions, and that'll give you the initial position, initial velocity, initial acceleration. All right. Part D. What does the word when mean? At what time t? Did y'all hear that? And I want you to understand that on the AP exam, they less frequently use the word when and more frequently use the phrase at what time t. Okay, they'll say at what time t does this occur, which is more explicit, that's clearer. But it's the same thing as when does this happen. When is the object moving right, moving left, and when is it at rest? Let's start with at rest. What does the phrase at rest mean? Correct, meaning the slope of which function?
The x of t.
Correct, the slope of the position function, okay? And the slope of the position function equals 0 when what?
V of t crosses the x-axis.
Yes, correct. It doesn't have to cross, but it has to touch the x-axis. Means that when velocity equals 0. It's very important that you understand the difference between this, when velocity equals 0, and this, velocity at 0. What's the difference between this and this? Correct. In this one, the input is 0. In this one, the output is 0. So what you have to... Can anybody think of how you could solve this? If you knew the velocity function and you had a graphing calculator, what could you do? Graph the velocity function and find the zeros. I got tissue. I don't. Hang on. I don't. Sorry, man. It's all right. Oh, dart. Okay. I got over that joke last year. Took me about a month, the first month of school. And then this year it caught on. Everybody else started. I was like, I already used that joke for a month last year. his name is Mr. U, you can see the possibilities, right? I mean, how many times have people used the joke when with you? Has anybody? No? No?
I do it myself.
You do it, okay. All right. Yeah. But anyway, I think Mr. U, he just laughs because when it's your name, I'm sure you hear it your whole life, and it's like, you wait for them to get over it. You know what I mean? It's like funny to the first person, when they first meet him, but after a while, it's like, I'm like, he's probably tired of those jokes. Yes.
Everybody always, like at work, always sing the Lady Gaga song.
Yeah. What is in the song?
It's called Alejandro. So.
Wow.
Really motivated with them.
I don't know. Yes.
Bring us some tissue.
Yeah. You're probably gonna have to run to the bathroom. He was just asking for tissue. Here. Yeah. Bring some back. Okay. All right. Yes, I have not been plagued with such things because for some reason nothing about my name is familiar to anything else in the English language.
Everybody pronounces it. I've heard Bond.
Yeah.
Like multiple things, like they'll make James Bond jokes.
I have another Bone. I have Abby Bone, but I think it's spelled differently.
Yeah, it's a different
But it's the
spelling.
same pronunciation, I think. Yeah. Do you know her?
No,
But you
other teachers-
have mentioned her, yeah. Yeah. Anyway. All right. So at rest means where velocity is 0. So you can just graph the function and then find the zeros. Any technique for finding the zeros of a function can be used to determine where a function, an object, or when a function is at rest. And then your answer would be a t value. Okay, so you'd say, well, at time 2.3679, the object is at rest because the output of the function at that time value is, the output of the velocity is 0. Okay, so now let's talk about moving right and moving left. These words, what kinds of words are they? Okay, positive and negative, that's good. So right represents positive motion and left represents negative motion, right? Now, understand also in some of those questions that I gave you, instead of saying when is it moving right or moving left, what do they say? Anybody? I don't know if anybody read through all of them, but did anybody notice in the second set of questions, it says moving up and moving down, or moving forward, moving backward? Do you see that? Okay. But think about the words right, left, up, down, forward, backwards. They're not position words. They are direction words. See, yes. Okay. Well, I'm sorry, Eder, what did you say? You had said something too. Well, yeah, well, it is. I mean, but they're shifting in a direction. These are words of direction. And which of the... So, to clear this up, we have 3 things. We're always dealing. Every time there's a question, I'm going to say, does position answer that question? Or is the question asking about position? Is it asking about velocity? Or is the question asking about acceleration? Well, if the question is asking about direction, which of those 3 functions represents direction? Velocity. And what about velocity answers this question?
The SIGINT.
The SIGINT. Yes. Whether velocity is positive or negative. And so what you're looking for here is moving right is a time interval. It is a time interval. Okay? Oops, that's intervan. Or interval. A time interval, okay, when velocity is what? Positive. And how do we say positive in mathematical language?
Increasing.
Oh, I see what you did.
Greater than
0.
0. When velocity is a time interval where velocity is greater than 0, right? If velocity is a derivative, what have we always understood about the derivative being greater than 0? What does that indicate on the function it came from? But the slope is positive. That means when the velocity is greater than 0, then on the position function, the graph must have a positive slope, moving to the right in a positive direction, where on the position function, down would be left or a negative direction. And what would you need in a function to move left? What kind of slope? You would need a negative slope in order to move left, which is why moving left is a time interval when velocity is what? Less than 0. When velocity is less than 0, when the derivative is negative, that means the position function, the original function, has a negative slope. Okay. So all we're doing here, if you look at some of my answers, you'll see that on part D, what I did was I wrote at rest, and then I put a bunch of t values. And those were all the zeros of the velocity. And then I put m right, and I put a bunch of time intervals where velocity had a positive value. And then I put m left, and I put a bunch of time intervals where the derivative had a negative value. Okay? Yes. Well, and it depends on what you're being. I am not going to ask you all three of these questions in one question. On the test, what I'll do is something like this. So question number 7. Here's the position function of an object. When is this object at rest? And then what would you have to do?
Just find what the velocities are.
Right, and how would you find the velocity?
The derivative.
Find the derivative of the function that I gave you, and then do what with that? Not plug in 0, that would be the initial velocity.
You have to graph it and then find where.
Find the zeros. Yes, very good. Okay. What is that also known as? The critical values. That's right. Those are the critical values of the position function. It's exactly right. At rest is the critical values of the position function. Yeah. All right.
I want to be Mr. U when I grow up.
Me too.
I want to be that Asian parent.
That was good. I want to be you. Okay. E. Question E. When does the object change direction? Every time you see the word direction, you should be thinking of velocity. That's right. So, if we have two kinds of direction, because we're on remember, rectilinear motion, it's one-dimensional. It's not doing this, okay? It's going back and forth. That's it, right? So there's only there's only two kinds of changing direction. There's going right and then going left, and then there's going left and then going right. That's it. Those are the only two choices. You're either changing direction from right to left or from left to right. How would we know when that happens? Does it say when the object changes? Yeah, when does the object change direction? No. I see what you're thinking, but not quite. Direction means velocity, right? Okay? What do we know about velocity when it's going to the right? When the object is going to the right? And? Well, it's going to happen at a 0, right? To go from positive to negative, it has to happen at a 0, right? Okay? And or what else? What's the other possibility? Going from positive to negative
Or negative to positive.
or negative to positive, right?
It sounded like you were asking.
Yeah, sorry. When what goes from positive to negative or negative to positive? when the velocity. Sometimes I feel like the back row gets left out. Do I leave you guys out a lot? You guys? Yeah, you guys are good, but you're a quiet group. A bossy, he's your representative back there because he keeps me connected with you guys back there. You too, Kat, actually. I understand. Rest it. Yeah. Yeah. All right, so we can identify at what times the object changes direction. They are times, okay, t values, times when v of t, the velocity, changes what? Let's say it is one thing, changes.
Direction.
Yeah, no, the object is changing direction. Velocity is changing sign or sign. Yes. When velocity changes sign. That's it. By the way, what does that, what happens? You mentioned it before. Velocity, or a function changes sign when it equals 0. Well, didn't we already find the zeros of v of t?
That means it's going to help you.
Right, but what question did we answer? At rest. Look, at rest means where velocity equals 0. So, that must mean that when an object changes direction, it must be at rest. So it moves in one direction, and then it takes a rest. And then it goes the other direction.
What's the difference between the initial?
Initial is where t is 0, not the output 0. Input of 0, not output of 0. Do you see the difference? So now a change in direction is simply a time. Now, an object can be at rest and not change direction.
At neither point.
A neither point, that's right. Yep. That's where it's moving to the left, and then it rests. And then it continues moving to the left. See? Okay. All right. Let's look at F now.
Wait, how could that help? Like, you stop at a stop sign where you
Yep.
don't stop.
And then you keep going. That's right. So you pull up to a stop sign, stop, and then move forward. There was a really neat story I read about a physics professor that did a research project and brought a proof to court when he received a ticket for not stopping at a stop sign. You heard about that? Yeah. How long do you have to stop at a stop sign in order to have stopped?
It's a limit.
3 seconds.
I don't think there is a law. You just have to stop.
Yes, but like my friend got pulled over for that. Like, he stopped,
Uh-huh.
and then like there was nobody there, and
Yeah.
he just kept going.
Yeah.
And they were like, sir, you didn't stop."
I believe that there are police officers that do not understand calculus. They don't understand instantaneous rate of change. In order to stop, you only have to stop for an instant. It does not have to be an interval of time. You can stop for an instant. There's a problem in one of these textbooks where it says a person in a stick shift stops at a stop sign at the top of a hill. And they roll backwards, and then they go forward, and then they get pulled over for not stopping at the stop sign. Well, they actually stopped twice.
They pulled my mom over.
Yeah.
And nobody was there, and she rolled a little bit. And
Yep.
wasn't fully stopped, and then kept going. And they're like, "You need to completely stop." She's like,
Yeah.
"There's nobody there."
Yeah. Well, here's the thing is what the physics professor did was the physics professor proved, because the police officer's vision was obstructed, and he proved that it was possible that he had stopped by using mathematical theorems.
Genius, bro.
I feel like that's what
Start doing
Patel does whenever he gets a speeding ticket.
Yeah.
I'm gonna do
Yeah,
that.
he always says it's like when the cops chase me, he said I escape them using physics.
Yeah.
This basically means he speeds and gets off the exit.
He said, I escaped.
The bottom line is this, is that stopping, an object can stop for an instant. It doesn't have to stop for a period of time. Okay? Did I show you guys how I could make an object stop in midair? Yeah.
That was cool.
There you go. HMAX.
Blew my mind.
Oh, you weren't here. Yeah. So it stopped. It changed direction, right? If it changed direction, it stopped. It had a velocity of 0 at some point. Yeah. That's it. Okay. F. All right. What is the object's position and acceleration each time it changes direction? Okay, so F is actually pretty easy. What is the object's position and acceleration each time the object changes direction? So think about how would we find the position of the object at any time? No, that would be the position is 0. It would be at the origin.
Oh, plug it into the original equation.
Plug what in?
The time.
The times when the object is changing direction. You would take your answers from E. I don't know if you're hearing me. You take the times when the object changes direction and then plug those times into the position function and the acceleration function. That's it. Yep. Plug answers from E up here into x of t and a of t. If you look at my key, I don't know if you can right now, but like under F it says so the answers for E are like t equals 1.4257, and then under what is the object's position, I say x of 1.4257 and then a of 1.4257. Okay. All right. G. We're getting there. I'll probably have to erase at some point, or I'll squeeze something in over here, maybe. All right, G. What is the object's maximum and minimum velocity, and when do these happen? What is the object's maximum velocity and minimum velocity? What does that sound like? The thing we just did. Maximum and minimum, an optimization problem. So all you have to do for G is do the absolute max and min of what? Of the velocity function of v of t. There we go. Just do the other thing we just learned how to do, but do it to the velocity function. And you're going to be given a closed interval. You'll note on every one of these questions, I give you a closed interval. 0 to 7 on the first one, 0 to 7 on the second, and 0 to 8 on the third one.
Wouldn't G and J be essentially the same?
Very close, but I must clarify an important difference.
It's not direction.
Yeah, correct. We have to take out direction. Okay. Let me do H and I real quick. H, I really want to spend most of the time on K. In fact, I'm probably going to start the video over when we work on question K. Question K is going to take a little bit of time. All right, so H. H says, oh, and notice what I said in G. It says, when do these happen? What does that mean?
At what time?
At what times? What are the times that these... So remember how I said that when you're doing maximum and minimum questions, sometimes you might be asked for the output, what is the maximum velocity? And then you might be asked for the input, when does the maximum velocity occur? Okay, because that's important too. It could be that you have a device on a machine that you want for its best effectiveness. You want that machine to activate within a second of when the machine reaches maximum velocity. Does that make sense? If it goes off too early, it won't affect the object as well as if it goes off when it's at maximum velocity. So you want to, and then if you set it off too late, you won't get enough of the effect of using the machine. So you want the machine to go off. I mean, I don't know, I'm thinking like, I'm sure there's something.
Like nitrous.
That's what I was thinking, something like nitrous. You want the vehicle to be at a certain velocity when you activate the nitrous. Yeah. Okay, so can you feel the engineering? Okay, all right. Good. Also, what about shifting gears? You want to shift gears when the RPMs of the shaft are at a particular are at a particular level. Yeah. Okay. And technically, you probably don't have an optimum. You don't have a change in. Well, you will have a change in RPMs when you shift. But if you don't shift, you're just going from 0 up to whatever's going to blow up the engine. So yes, which is why you shift. So. Yeah, I don't recommend. If you just drive your car and max out at about 2,500 RPMs, you save so much gas. If you drive, anybody here drive a stick? Drive a stick. Love it. Yeah. I had a Honda Civic, 1994 Honda Civic stick shift. I could get in front of a Corvette at a red light because I could, now he probably wasn't trying. This happened one time, okay? Because I could get off the line really fast. After that, it's all, the speed is, the acceleration was great at first, but then from there the speed just climbed a little slow. What's that? Initial acceleration was great. From there, everything just fell off. Uh-huh. Yeah.
Like everybody had left, so we were racing on the road.
Uh-huh.
And white people. Okay. Anyway, so we had my dad's F-150. It's got the eco-boost in it.
Okay.
So the first part of it doesn't get really fast.
Yeah.
And my uncle's I don't remember what year it is. It's a Buick, but the initial takeoff on that's really fast.
Yeah. Uh-huh.
So he had him.
Yeah.
And then
At
my
first.
Dad, passed
Yeah,
him.
that's the difference between, I don't know if you've ever heard of, I'm not into car racing, but I had a friend who was into car racing. There are there are different events, so to speak, and one of them I think is like the quarter mile. And so people who are doing quarter mile races, they're putting everything into what happens in the first couple seconds, And apparently, like if you can do it in under 10 seconds, there are laws that say you have to have a roll bar in the car and that kind of stuff because it gets more dangerous when you get up to those speeds. Yeah, in the long run. Yeah.
During the Olympics, once Usain Bolt, it always looks like they're gonna beat him, but it's always in the last 30 meters that he
Isn't that amazing?
Because when they reach
Yep.
the speed,
Yep.
he's still going.
Yep. Yep. There you go. That's why. So I mean, all of these things. I mean, you can see it. It doesn't have to be a mechanical sport. All kinds of sports can benefit from understanding calculus with velocity and acceleration and that sort of thing. I mean, I don't know what in softball, the fact that you're only ever running short distances, right? You're not running in a straight line the whole time. You have to slow down, touch the base, turn 90 degrees, and then speed up again. That's a big deal. And you're only allowed to overrun first or something? Yeah. Yeah, but other than that, you need to...
Yeah, that's why we're told to take wide turns.
Yeah. Because if you get it onto to make it more like a circle, you can maintain a high velocity and not lose energy as you're coming around. But then, of course, you don't want to get too close to the players that could potentially have the ball and then, tag you out. Can you really toss a ball at somebody to get them out? No? Okay. I've heard that before, yeah. Yeah, like if you get hit by the ball, you're out or something. I don't know. But do you have to tag somebody with the mitt that has the ball to get them out?
On first base and they hit the ball and it's like a ground ball and it hits you, then you're out because it's like interference with the play.
Got it, okay.
But if they field the ball and then throw it at you.
Not okay. Because that would probably encourage people to start chucking the balls at each other, right? Now, can I catch the ball here and then tag you with my left hand?
No.
I have to tag you with the ball. Okay. Well, now if I have the ball in this hand, then I can. Okay. All right. All right. You can tell how much I know about sports. Yeah. What happened? All right. Let's go on. You wrap that up, and I'm going to go on to H. All right, H. In fact, let's just talk H and I. H. What is the object's maximum and minimum acceleration? Any questions? All right, you guys okay with H? Is just do absolute max? Do absolute max and min of A of t. Now, sometimes question I requires a little bit of conversation. Question I says when is the object farthest to the right and farthest, oh, I should have said, where is it? Oh, I was supposed to be, where is it farthest to the right and farthest to the left? And then when do these happen? Sorry about that. Well, it'll be better on the test or on the review. All right, what does it mean? What does farthest right and farthest left mean? Yeah. Yeah, what a max and min of what? The absolute maximum and absolute minimum of?
F of x.
Of x of t, of the position function, yes. So farthest up is the maximum of the position function if it's an up and down function. Are you okay, Catalina? I'm so sorry, and I'm so loud. Do you want to move for now? Okay, all right. So basically, farthest up, farthest down, highest, lowest, closest, farthest. Does that make sense? These are all, if it's a position word with an ist on it, okay? It's the absolute maximum. Do the absolute maximum and minimum of the position function. I'll put of x of t, okay? X of t is a general phrase to refer to the position function, even if it's a y of t or a w of t or something else like that. All right, J. Let's talk about J, and I'm going to put it next to G because that's where Kenneth wants me to put it. Let's talk about J. Okay, because this is what J says. It says, what is the object's maximum and minimum speed? The maximum and minimum speed.
Speed is
No, well, speed is
velocity without direction.
velocity without direction.
The absolute value of
The absolute value of velocity. So what you're trying to do here is do the absolute max and min of the absolute value of velocity. Now, what is the lowest possible number that you can have? What is the lowest value you can possibly have on minimum speed?
0.
0, that's correct. So if the velocity function touches the x-axis ever in your problem, then the minimum speed is 0. That means at rest. If the object is ever at rest on that interval, then your minimum speed is automatically 0, which means it can happen multiple times. In fact, when you look at my key, you'll note that when I answer that question, I put minimum speed is 0, and then I gave all the times when the object was at rest. Okay? All right. But the maximum, here's what you would do. What if the maximum velocity was 40 and the minimum velocity was negative 70?
The maximum.
Then what would the maximum speed be?
70.
It would be 70 because the absolute value of negative 70 is 70. And that's larger than 40, right? It just happens to reach its maximum speed in the negative direction. Does that make sense? Okay. All right, great. Yeah. Mm-hmm. Yep, it's still velocity, but it's all the velocity numbers are made positive if they're not already positive. Yep. So let me give you an idea. Let's say that we have a velocity function that looks like this. Okay? The speed function would look like this. The negative portion would have to be reflected because it can't be negative. So then this would be a speed function. It's, speed increases, speed decreases, it stops. Speed increases, speed decreases, it stops. Speed increases, speed decreases, it stops. But this portion right here would be leftward speed, this would be rightward speed, and this would also be rightward speed. Okay? We're doing okay. All I'm trying to teach you is the beginning world of mathematical physics.